So our first question, Jonathan has a fair six-faced dice which has the numbers 1, 2, 3, 4, 5 and 6 on its faces. Jonathan rolls his dice once. On the probability scale below, mark with a cross the probability that the dice will land on an odd number. So the possible chances of it landing on an odd number are a 1, a 3 or a 5. Now there's 6 possible choices, 1, 2, 3, 4, 5, 6. 3 of them out of 6, okay, could be an odd number. 3 out of 6 is the same as 50%, half of them. The second question then, Cassia has a fair 8-sided dice, which has the numbers 1, 2, 3, 4, 5, 6, 7, 8 on its faces. Circle the word from the list below that best describes the likelihood that the dice lands on a 9. Well, there isn't a 9 on the dice, it only goes up to 8, so it is impossible. Cassia rolls her dice 80 times. Work out the number of times you would expect her dice to land on a 5. So what we want to do here, the chances of it landing on a 5, there's only one option out of 8 for it to land on a 5. 80 times 1 out of 8 is going to tell you how many times it's likely to land on a 5. Okay, 80 times 1 out of 8, you can use your calculator, is 80 over 8, which is 10. So 10 times. Okay, so this one is 2 marks. So if we've written down this calculation, 1 mark, and 1 mark for our answer. Okay, D is Jonathan's going to roll his dice once, Cassia is going to roll her dice once. Is Jonathan more likely to roll a 6 than Cassia? You should justify your answer. If you look at the options, so Jonathan was the one that had a dice with 6 sides, 1, 2, 3, 4, 5, 6. Cassia has the options 1, 2, 3, 4, 5, 6, 7, 8. So Jonathan has one option out of 6 to roll a 6, and Cassia has one option out of 8 to roll an 8. So we want to say that Cassia's dice has a 1 in 8 chance of rolling a 6, and Jonathan's dice has a 1 in 6 chance of rolling a 6. Therefore, it's more likely that for Jonathan to roll a 6 than Cassia. So for 1 mark, we needed to have said that Cassia's dice has a 1 in 8 chance and Jonathan's dice has got a 1 in 6 chance. You may have worded that like Cassia's dice has got more faces and Jonathan's dice has got less faces, something like that. And then you need to, your second mark here is for saying that therefore it is more likely for Jonathan. There's your second mark. So a town council is proposing to build a new leisure centre. Michelle is going to carry out a survey to find out what all people think in the town of the proposal. Michelle thinks that she should take a sample rather than a census. Give 2 reasons why Michelle might think this. Remember, a census is the whole population and a sample is just a selection of that population. So I've written 4 possible options here. You need to have any 2 of these possible options. So a sample is easier than using the whole population. Obviously it's less people, so that's going to be easier. It's cheaper to send a survey to just a sample rather than the whole population. It is quicker or less time consuming to send a survey to just a sample of people, and it will then generate less data for them to have to analyse. So any 2 of those 4 reasons you could have. So 1 mark for each reason. 1 mark for each reason. Michelle plans to use the electoral register as the sampling frame. Explain what you understand by the term sampling frame. A sampling frame is just a list of the whole population and then you pick your sample from that list. So all we need to say for that 1 mark is a list of all the population. Give 1 problem Michelle may have using the electoral register as a sampling frame. The electoral register, for context, is people register themselves on that so that they are able to vote in the kind of government elections, local elections. So it's something you have to register yourself to in order to vote. So some possible issues of Michelle using the electoral register as a sampling frame is that children are not on the electoral register, because obviously to vote you have to be 18, so children aren't included. Only people registered to vote will be included, not everyone does register to vote, and the electoral register is actually confidential, so the access to that might be limited. So you only have to give one problem, so any one of those possible issues, any one of those for your 1 mark. Michelle intends to conduct a pilot study. Give 2 reasons why it's a good idea to conduct a pilot study. Remember, a pilot study is a small-scale study that we do before the full study. The reason we do that is to identify any issues before the full-scale study, to check the questions work as we want them to work, to make sure the questions are easy for people to understand, and to get an idea of the response rate, so how many people are actually going to respond to our survey or questionnaire. It's 2 marks, so any 2 of those possible reasons, 1 mark for each. So any 2 of those possible reasons, 1 mark for each. Michelle is writing a plan for her investigation into people's views on the leisure centre proposal. Write down what Michelle should include in her plan. You should include each of the following: a sampling method, a question she could ask in her questionnaire, a statistical diagram she could use to show the results of the survey. Explain why each of the things you have written down is appropriate. Now this is 6 marks, so we have to give those 3 things, a sampling method, a question and a statistical diagram. So that's 3 things, plus we have to give a reason why we've chosen that. That's another 3 things, so that's where our mark comes from. 1 mark for each part here and 1 mark for the additional reason. Okay, so that makes up 6 marks. So Michelle should use a random sample of the people in her town, because every resident has an equal chance of being selected. No, you could have chosen a different type of sample, stratified, opportunity, but then your reason would be different. Okay, so you can get 1 mark for your chosen sample, okay, and then 1 mark for your valid reason. Okay, if we've chosen a random sample, the reason we would use that, the good thing about a random sample is that everyone has an equal chance of being selected. An opportunity sample, for example, we might use that because it's easy for Michelle to do. Okay. A question she could ask is, would you benefit from a new leisure centre, with the option yes or no to answer. So there's my question. This is a good question as it is non-leading and a closed question. So that's my reason. Okay, I've given a valid reason there. I've chosen that question because it's non-leading and it's a closed question. It's either a yes or no answer. Okay, and then I've chosen a bar chart. So that's my selection. Would be a good statistical diagram as it clearly shows the frequency, so the amount of people and of the answers. Okay, so that's a possible option. Obviously with your question, you might have a different question as long as you've got that valid reason, and your statistical diagram, you might have chosen something different, like a pie chart for example, or a pictogram, again as long as you've got that reason to back it up. So question 6, David asks 15 of his friends about the number of pets they each have. Here is the data he has collected. Circle the word in the list below that describes this type of data. So we've got numerical data, that makes it quantitative. So already it is not qualitative because we've got numerical data. We can see really clearly it's not grouped. Okay, so my 2 types of quantitative is either continuous or discrete. The number of pets is specific values. You cannot have 2.247 pets. Okay, so they're specific values, which makes it discrete data. Okay, so 1 mark, discrete data. The modal number of pets, that's our most common, the mode. Okay, our modal number of pets, the most common is 0. So most common is 0 pets. And then it says find the median number of pets. Remember, that's our middle value. when they are in order. Now thankfully they are already in order. Okay, so my middle value, so if you wanted you could come in like this until you get to the middle value. Our median is 2. Okay, 2. State which average, the mode or the median best represents these data. Give a reason for your answer. So I've written, as the mode is 0 and there are clearly people with more than 0 pets, the median would be more representative. Okay, so if we're saying that on average people have 0 pets, that's clearly not right because there are lots of people with more than 0 pets. You may have said we've chosen the median because it's the middle value. We may have said we've chosen the mode because it's the most common. Okay, so there are different options here. So the mode because it's the most common, the median because it's the middle value, or the median because the mode ends up being 0, and that just doesn't make sense. Okay, so one of those 3 reasons for that mark. So the next one says to find the interquartile range of the number of pets. So the interquartile range is the upper quartile subtract the lower quartile. So to find the lower quartile, okay, if this was our median, we're now going to find the halfway point between these two values, these sets of numbers. So halfway is going to be 0, that's our lower quartile. And then our upper quartile is the middle value on this half of the numbers. So our upper quartile, 4. So if our upper quartile is 4, the lower quartile is 0, 4 subtract 0 is just 4. Okay, so if you've got that, great, 2 marks. If you don't have that, but you have identified the correct values here, okay, 4 and 0, then that's still 1 mark. Wanda asks some of her friends about the number of pets they each have. The table below is a summary of the data she's collected. So they've not given us the individual values, just the lower quartile, median, upper quartile. Compare the distribution of the numbers of pets for David with the distribution of the number of pets for Wanda. Give 2 comparisons and interpret each of your comparisons. Essentially, if we're talking about the distribution numbers, we want to say something about our average, and we've got the median here, and we want to say something about the interquartile range. Okay, so we're going to say one of them has a bigger or smaller median, this suggests. One of them has a bigger or smaller interquartile range, this suggests whatever. So the median for Wanda, being 3, is greater than the median for David, which is 2, 1 mark. So David's friends on average, you have to state on average because we're talking about an average, the median, have fewer pets than Wanda's. So we've compared the medians, we've said that means on average David's friends have fewer pets. The interquartile range is smaller for David, 4, than for Wanda, which is 5. Comparison. And then our interpretation is that the spread of the number of pets for David's friends is less varied, that's the key term, than for Wanda's friends. Okay, so if we're talking about an average, median, mean, mode, we need to say that on average. And if we're talking about the interquartile range or the range, we're talking about the spread of data being more or less varied. So that's where your 4 marks come from. Wanda recorded the highest number of pets as 15. She says that this must be an outlier and concludes that it should be removed from her data. Give 1 reason why that may be appropriate. So we might remove the outlier because it will affect our statistical calculations, like finding our mean, median and mode, or the interquartile range. It's going to kind of, the mean, it will skew. And it may be that that outlier is incorrect. So any one of those 2 reasons, so 1 mark, either of those, the data might be incorrect if it's an outlier, or we're going to take it out because it will affect our statistical calculations. So one reason that it would not be appropriate to remove the outlier is that actually may still be a genuine piece of data. Okay, someone may genuinely have 15 pets. Okay. The following is an extract from part of a row of a random number list. Use the random number list to complete the table for the first 5 random 2-digit numbers. So they've started with 68, so the next 2 digits, 23, the next 2 digits, 63, the next 2 digits, 53, the next 2 digits, 35. So you get 2 marks for all 4 correct. Okay, 1 for at least 2. So at least meaning 2, 3 or 4 correct. Okay. So the most common blood type in the UK is O positive. The percentage of people in the United Kingdom with O positive blood type is 38%. Asher uses a simulation method to estimate how many donors would be needed to find exactly 3 donors with O positive blood type. Asher is going to use the following 2-digit number system for her simulation. So applying random numbers to people, and then you would kind of see how many you'd need to go through, how many people until you get 3 O positive. Explain why this is an appropriate way to allocate the random numbers. It's appropriate because in her table, 0 to 37 out of 100 in total, because in total she's gone from 0 to 99, that's 100 numbers. 0 to 37 would be 38 out of 100, which is 38%. So the 0 to 37 represents 38 numbers of 100, so that is 38%. So Asher runs trials using her simulation method. The result of each trial is the number of random numbers used until she gets exactly 3 donors with O positive blood type. The table below shows the results of her first 4 trials. So in her first trial, it took 7 random numbers to get 3 donors with O positive blood type. In the second trial, she only needed 5 random numbers to get 3 that are O positive blood type, and so on. The set of random numbers used by Asher to complete the 5th trial are shown below. So these are the random numbers. Using this set of random numbers, find the result for the 5th trial. You must make it clear how you obtain your answer. So first random number that's not between 0 to 37, so that's not O positive. 13 between 0 to 37, so that is O positive, so I've underlined it. 12 between 0 to 37, so that's O positive, underlined it. Not O positive, not O positive. This one between 0 to 37, so that is O positive. So we've got our 3 donors there in those 3 numbers, and that's 1, 2, 3, 4, 5, 6 random numbers needed to get those 3 donors. So 6 random numbers are needed to obtain 3 donors, as 13, 12 and 10 are within the first 6 random numbers. So if you've got the values 13, 12 and 10, and that is your first mark. And then your second mark is for stating that requires 6 random numbers to get those 3. Okay, so we have to have these first 6 in order to get those 3, 13, 12 and 10. Asher finds the mean of her 5 results and decides that the results of her simulation are sufficient to predict the number of donors needed to find at least 3 with O positive blood type in the next blood donation session. Explain whether the method that she's used to predict the number of donors required is appropriate. So we could have either one of these 2 answers. So our marks come from stating it is appropriate or it isn't appropriate, and then our reason why. Okay, so 1 mark for stating whether it's appropriate or not, 1 mark for stating why. So one answer that we could have, it is appropriate, 1 mark, as the sample mean is likely to be close to the population mean. So she's used a sample, that average is likely to be close to the population. So appropriate, reason, 2 marks. We may have put it is not appropriate as she has not done enough trials to predict for the whole population. So not appropriate and our reason, 2 marks. So one of those 2 answers we could have. Claire is investigating sales of different types of vehicle over time. She plans to collect data on the number of motorcycles first registered in the UK over time. Write down a suitable hypothesis for the investigation. Remember, a hypothesis is just a statement of what we think is going to happen. So I've written the number of motorcycles first registered in the UK is increasing over time. You may have put decreasing over time. It's just a hypothesis. So we don't know yet, we're just saying what we think will happen. We need to say the number of motorcycles first registered, and then we need to say increasing or decreasing over time. The time series graph shows some information about the numbers of motorcycles first registered in the UK from 2017 to 2019. So this is our quarter, so the first quarter of 2017, and then for the second quarter of 2017 it rises up. It drops down until the end of 2017, and then the first quarter of 2018 it comes back up all the way up for the second quarter, okay, and so on. So it says identify and interpret one example of seasonal trend shown by the time series graph, a trend being kind of like a repeated pattern, so a seasonal trend. More motorcycle registrations appear in quarter 2 each year. Which means more motorcycle registrations as the values are the greatest in quarter 2. So really we want to make a statement to identify that in quarter 2 they have the kind of peak, so the greatest values in quarter 2, and then the interpretation is that, well, that must mean that there's more motorcycle registrations. Okay, you may have said that the lowest values are seen in quarter 4, which means there must be the least motorcycle registrations in quarter 4. Claire calculated 4-point moving averages for the information shown in the time series graph. Explain why this is appropriate. So any one of these 3 reasons, it's only 1 mark. Moving averages allow us to see the trends, and the pattern is repeating every 4 quarters, so that's why we can use a moving average, a 4-point moving average, and it removes the seasonal variation by using the 4-point moving average. So any one of those reasons we could have for that mark. So Claire also collected data on the number of cars first registered in the UK from 2017 to 2019. The time series graph shows some information about the numbers of cars first registered in the UK from 2017 to 2019, together with the first 7 4-point moving averages. So this is the time series graph, and then these are the 4-point moving averages. Okay. Compare the seasonal trend shown for the number of motorcycles first registered in the UK with the seasonal trend for the number of cars first registered in the UK. So as a reminder, this was the time series graph for the motorcycle registrations. We saw the peak in quarter 2 and then the drop in quarter 4, okay, and that was the pattern for the motorcycles. For car registrations though, what we can see is that the highest values are always in quarter 1. So we could have said the greatest values for motorcycles are in quarter 2, but the greatest values for cars are in quarter 1. A simple comparison, we don't have to interpret it. A simple comparison, that's 1 mark. We might have said a different reason, a different comparison. Both cars and motorcycles have the lowest values in quarter 4, so for both cars and motorcycles, their lowest values are quarter 4. It's just a comparison, we don't have to interpret it, so any one of those 2 things. The last 3 4-point moving averages for the number of cars registered in the UK from 2017 to 2019 are 576, 575.3, 573.9. Plot these moving averages on the time series graph and draw a trend line. So we can't get too accurate because 550 is here, so 560, 570, and they are all in between 570 and 580, so somewhere in here. If we come across, we should have plotted it between the 1 and 2, quarter 1, quarter 2, one there between quarter 2, quarter 3, and the last one between quarter 3 and quarter 4. And then describe and interpret the trend in the number of cars first registered in the UK from 2017 to 2019. We could say something like, the number of cars first registered in the UK is decreasing over time. So that is because we can see the trend of our averages are slowly coming down. So that will get you 2 marks. Essentially 1 mark if we said something about it decreasing. Okay, but no context of the cars. Okay, so if we've just said it's decreasing over time, it's only 1 mark. If we said the number of cars first registered in the UK is decreasing over time, that's 2 marks because we need to have the context.